Alright, so in this tutorial here, we're going to be looking at how do we collect data for a Titration Curve Lab. What I have here is a pH probe. It's currently connected to our sparkling air. This one here is Bluetooth connected to my computer, and I've already opened our Capstone software. For the experiment here, in the burette here, currently I have 0.100 molar sodium hydroxide. It's currently sitting at the 0.00 milliliter reading on the burette. I pipetted in 10 milliliters of some unknown HCl solution here. This one here I've dropped in a little bit of phenethylene just so that you can compare to how we normally do titrations. Usually when the color changes, that's when we stop. We're going to find for our titration curve, we're going to purposely see the color change, see that transition, and actually purposely go past it as well. So I'm just going to show you how this is going to look like here. First thing you're going to do is you need to toggle for our capstone here, tell it we're getting data from the sparkling air. Again, just click the sparkling device here, give it a second to just figure out what sensor it is. Great, in port number 1 I have a pH sensor. I'm just going to close this tab here. I'm going to open up a default layout here that shows me some data tables here and a graph. I'm going to plot my x-axis here in time. I'm going to track how the pH changes in time here. I'm going to plot the pH on the vertical. Similarly, just plot the pH up here. Okay. And again, all you need to do here is you just press the record button, and that pH probe is just going to be sampling the pH as time goes onwards. So I'm just going to demonstrate for you the first time a little bit more simply. So I'm going to take this pH probe here. Currently it's just sitting in some water just to make sure the electrode doesn't dry out. I'm going to drop it into this Erlenmeyer flask here. It should be sampling the pH of this HCl at any given time. What I'm going to do here is I'm just going to open up the burette here. I'm going to run the clock when I do that there. When this actually hits 50, we can actually, using the time and using that we've dispensed 50, you can get a sense of the flow rate, and that way you can actually calibrate, depending on sort of how long it took for the reaction to occur here, we can match it up to the milliliters. So this is a slightly easier way, but slightly more inaccurate, just to give you a feel of what's happening. I'm just going to press record for now, so you can get a baseline of what's happening. Currently the pH is reading 2.7, which is expected for our unknown acid solution here. As I steadily open this base, I'm going to expect that the hydroxide is going to slowly neutralize the HCl. So it doesn't exactly matter how open I do this one here. I'm just going to maybe just twist it a little bit here, just let the solution in. I do want to be continuing to mix the solution. I'm going to stop my stopwatch and that happens. Okay. So basically the base is going into the Erlenmeyer. The phenethylene is sensing that there's base inside, so it's pink. And then all that's happening here is as it finds our unknown acid, it neutralizes, the pink color disappears. Okay. Right now here we dropped in about 12 milliliters, okay, just so we can get a sense of the flow rate. Normally for titration, when it hits like a pink color like this, okay, we would want to stop, okay? We would say, oh no, we've overshot, okay? This time here, purposely, we're going to overshoot that. The color has definitely changed here. Just going to keep going here. Since I have 50 milliliters of base in the burette here, I'm just going to go directly to 50. Okay, roughly about 50 seconds has passed by here, so hopefully you can get a sense of that flow rate here. And on our capstone here, it's actually showing us the pH changing in time. Remember, pH is a logarithmic scale here. As I get up into those extremes, it gets a little bit harder to actually get farther and farther along. This is an overly strong base here. So it's getting a little bit harder to actually get much farther. But again, all I'm going to do here is I'm going to just keep letting it go here. We've dispensed in about 30 milliliters at this point here. You'll notice that it's way pink. Normally we would have stopped the titration way before. But armed with a graph like this and the data table here, we can actually do some curve calculations. Where the pH suddenly jumps here is going to point out to us where the equivalence point is. We can do some calculations with pH half and volume half, the pH initial with an ice table to try to figure out the initial concentration. So just continue to swirl this around here. Okay. Again, this is sort of just giving you a feel of what's going to happen here. We'll do it once more, a little bit more accurately later on. Okay. I'll just let in the last 10 mils of base fall in there. I've noticed that this is going drop-wise. There's actually a device actually called a drop counter. So what you can do is you can actually put the drop counter here, and it can actually sample how many drops are actually dropping in. And that way we won't need to do a just sort of rough comparison. How long did it take for 50 mils to drop in, and sort of calibrate this time for us here. Okay. Again, slightly more inaccurate, but it's a little bit quicker. and I'm going to hopefully do it for you one more time, a little bit more accurately, a little bit more tedious, but again, all we're after here is a titration curve like this, and then we can sample our data. So we're just about down to the 50 here. This has been dropping dropwise. And I'm just going to close at 50 here. Okay. And there we go. It took about 2 minutes and 49 seconds or so for all the base to drop in. Definitely convert that to a seconds before you do any dividing. Give me a second to just reset, and I'll show you how we can do this a little more precisely. Thanks, guys. Okay, so I've reset the titration here. I've topped up our burette. Right now we're at the 0 milliliter marking. The solution is 0.100 molar sodium hydroxide. We're still going to be dropping the base here into our unknown acid. This was freshly pipetted here, 10 milliliters of some unknown HCl here. This time, instead of doing our mechanical stirring here with me swirling it, I've dropped in a stir bar here. We're using a stir plate to automate that. I still have my pH probe here stuck inside. Just be really careful. It's a fairly tight squeeze here. Make sure that the stir bar doesn't accidentally hit the meter. We don't want to damage the device here. This time what I'm going to do here is I'm actually going to drop in increments of base here. The pH meter here is going to sample for me the pH at that volume that I've dropped in. And basically we're going to plot a graph after the fact here, pH against, in this case, volume of base added. Hopefully we'll get a nice titration curve here. We'll be able to figure out where the steep jump is. That's going to be the equivalence point, and then do the remaining curve calculation. So what I have here again, our meter is hooked up to our sparkling air. It's connected via Bluetooth to my computer here. I already have Capstone all set up here. So our hardware is our sparkling air. It knows that in port 1 there's a pH sensor. Previously, this was plotted in real time. It was really convenient here. It plotted the time versus the pH. This time what we're going to do is we're going to just sample the pH here. I just want you to record the pH as I tell you how much volume my drop in is. So I'm going to just press record button here. Initially our pH is 2.1 when I've dropped in 0 milliliters of acid. I'm going to drop in this base here 1 milliliter at a time. All I want you to note down here is what the pH reading is. This numerical value might be easier to see, or there's a similar value. This should be the same data here. So let's just do it here. So again, we're at the 0 milliliter marking. I double checked that the solution is not going to accidentally hit the meter or the stir bar here. I haven't put in any phenolphthalein, so it's actually not going to turn pink. But fortunately for us here, for titration curve calculation, it doesn't matter what the indicator is. So 2.1 here is when there's 0 base added. I'm going to drop in a little bit here. So that's at 1 milliliter here. So 2.2. Drop in another milliliter. So this is the 2 milliliter mark. Still 2.2. Drop in another milliliter. We're at 3 milliliters. Still 2.2. Okay. Another milliliter. So this is the reading at 4 milliliters. Continue onwards here. This is 5 milliliters. Slowly coming upwards. We're going to go down to 6 milliliters. I'm dropping in roughly 1 milliliter increments at a time. Going down to 7. Let's take down that reading as 2.4. Increment of 8 milliliters. So still 2.4. We're at the 9 milliliter mark. So 2.5, 2.6 or so. Going down to 10. We have again 2.6. Drop in another milliliter here, 2.7. That's the 11 milliliter mark. Going down to the 12 milliliter mark here, we have a pH. Oh, you see it's starting to change much quicker, so it's going to be 3.1 here. So going down to the 13 milliliter mark, we have a pH of 8.9, 9.0. Okay, so somewhere in there, there was a really sudden jump here. I'm going to take another milliliter here. So this is the 14 milliliter mark. So we're definitely excess base. If there was phenolphthalein, it would have turned pink at this point here. 1 milliliter. So at the 15 milliliter mark here, 11.6. At the 16 milliliter mark here, still 11.6. 17 milliliter mark, 11.6. 18 milliliter, 11.6. 19 milliliter mark, 11.6. 20 milliliter mark, 11.6, right? So I'm noticing that that pH there is staying fairly steady. This base here isn't overly concentrated, so I do expect a rough pH around there to steady out. I've just taken down a few data points so you can get a sense of what that ending looks like here, but we definitely had some equivalence point here where that pH you saw jump really, really quickly. That's the part I would want to do in a little more detail, try to figure out when that steep jump really occurs so I can find the equivalence point. Thanks, guys. Alright, so I reset the titration one more time. Again, I pipetted in a 10 milliliter of unknown HCl solution here on the bottom. We have our pH probe here that's connected to our capstone program here. What I've done this time is I've actually diluted the base by 2. So previously it was 0.1 molar. Because I doubled the volume, we're about 0.5 molar right now. This will hopefully give you a little bit more details when we actually get around to doing our titration curve. Again, we're doing this sort of after the fact here. We're going to collect what the pH reading is as I drop the milliliters in increments. We're going to see what we get afterwards. So let me just double check here that the stir bar here isn't actually hitting the meter. Okay, we're going to have a starting reading. I've topped up the barrette here to 0, so the pH here is currently 2.2. I've double checked that the nozzle itself is not actually going to hit the pH meter, so any base that I drop via the barrette, it's actually going to go into the solution. So let's just have a look here. So starting reading here 2.2. I'm going to drop in 1 milliliter here, close the valve, so still 2.2. 1 milliliter, 2.2. At the 3 milliliter marking, we're at 2.3. At the 4 milliliter marking, we're still at 2.3. At the 5 milliliter marking, 2.3. At the 6 milliliter marking, 2.3. 7 milliliter marking, still 2.3, 2.4. 8 milliliter marking, 2.4. 9 mil marking, 2.4. 10 mil marking, still 2.4. Remember that equivalence point here happens fairly quickly, so 11 milliliters, 2.4. 12 milliliters, 2.5. 13 milliliters, 2.5. 14 milliliters, 2.5. 15 milliliters, 2.6. 16 milliliters, 2.6. 17 milliliters, 2.6. 18 milliliters, 2.6. 19 milliliters, 2.7. 20 milliliters, 2.7. 21 milliliters, 2.8. 22 milliliters, still 2.8. 23 milliliters, 2.9. 24 milliliters, 3. 25 milliliters, 3.1. 26 milliliters, 3.2. 27 milliliters, 3.5. 28 milliliters, 3.8. 29 milliliters, 6.8. So we're getting close to the equivalence point here. 30 milliliters, 10.4. 31 milliliters, 11.2. 32 milliliters, 11.5. 33 milliliters, 11.6. 34 milliliters, 11.6. 35 milliliters, 11.6. 36 milliliters, 11.6. 37, 11.6. 38 milliliters, 11.6. Go 2 more. 39 milliliters, 11.6. And 40.0, 11.6. Okay. So you saw us go up in 1 milliliter increments. There's nothing magic about the 1 milliliter. I just wanted to take down enough data points here so that I get a nice curve here. Hopefully with those data points here, you can draw a nice smooth curve going through it, where it jumps from the last acid particle through a neutral solution to the basic solution here. It all happens within a very narrow range of pH. That's going to be your equivalence point here, and then you can practice your curve calculations shortly. Again, the difference between this trial and the one that we just did, we had diluted the base solution so that the concentrations here were a little bit more different, and that's why I took a little bit more volume of base before the equivalence point was reached. If I had phenolphthalein, this one here would be a deep pink. It would have turned pink way before, but again, we have a pH probe in there. We're going to be analyzing this graphically. All right, so thanks guys.